Excellent. And I'll talk to you about the homework that's here later after we finish today's section of notes. It's fairly brief, and today is a double period, so we will take a break in between. Although it may not be exactly at the passing period. So where am I trying to go? This is where I need to be. There we go. So this is our presentation. By the way, all of the presentations I have been uploaded to Google Classroom. So if you ever can't get something down in your notes fast enough, you can go back to the recording of the class, or you can just go to Google Classroom and look at the PDF of the slides. And then you can get them. Some students I've had in the past have been I call them overachievers. They saw that the slides were posted. They went to the library, printed them all out in color, and had them in their notebook. They never had to write anything down except any annotations or additional things I said. So if you want to do that, you should feel free to do that too. I'll show you where they are in Google Classroom in case any of you meet that description where you want to do it. Here we are in our Google Classroom. You know, at the top, we have these different sections. It's under classwork for our class. And then under the topics, we're going to look for the unit that we're in. We're starting off today with Unit 1, which is called the Mathematical Toolkit for Physics. If we click this, you'll see here's the PDF of the slides that you'll see are going to mirror exactly what I'm putting on the screen with you. Just going through a little too fast. It's just, they're all there. All right, so you can, there you go. They're there along with the packet. If you ever lose the packet that I'm going to give you that goes with the unit, you can go there to print out the pages you need, or you can go over to the bins. I have all my extra handouts over there too. Okay, and I do have a few extra. Okay, that's enough of that. Let's get into this. So Unit 1, there are 16 units in the course, if you're interested, 16 of them. Unit 1 is the most science skill related unit. It's about the math skills that we need to have in order to do things in physics. Okay. And as we saw yesterday with that little video, math does play an important role in physics. It becomes more prominent as you go through physics, as you go to higher levels of the course. In this level of physics, we need to have a basic understanding of algebra and a basic understanding of a right triangle. That's it. Okay. So that's what we're going to be looking at, plus some other like graphing skills and things like that. One of the things we do in all science courses is we make measurements. That's what scientists do. We make lots and lots of measurements in laboratories. And then we analyze the data that's collected to look for trends. What is Mother Nature trying to tell us with the data? So what we're going to do is explore two vocabulary terms in this section of the unit. Today, we're going to look at the term precision. What does it mean when we talk about the precision of a measurement? And also, how do we make a measurement correctly? And then on Monday, we're going to learn what we mean by accuracy. What does it mean when a measurement is accurate? Because we try to be both. We try to do both things. Now, the next slide in every presentation is the objectives. What are the learning objectives for the student? What do I expect you to be able to do by the end of this? Do you have to write those down? No. I'm just going to kind of verbally tell you what you need to be able to do. And if you ever need to go back, you can look at them in Google Classroom. All right, so you don't have to write them down and take your time with that. So what I will be testing you on is the term precision. What does that term mean? Explain it in your own words. Then can you make a measurement using proper technique? Your assignment this weekend and in our first lab is to be able to do that second bullet. Can you make a measurement using the proper technique? Then on Monday, we'll learn what the term accuracy means. Can you explain that? Can you calculate a percent error? I'm pretty sure most of you have done that if you've taken the Regents Chemistry here. That's part of the Regents Chemistry curriculum. We use it here as well. And then finally, if I were to give you a group of measurements that students made, could you look at that group of measurements and tell me which one was the most accurate measurement, which one in that group was the most precise measurement, and tell me how you know. Okay, that's really what we're trying to be able to do with this. All right, let's get into precision. What is precision? Precision refers to the degree of exactness with which a quantity can be measured. How exact is a measurement? Now, what's really interesting about precision is that we can determine the precision when I look at a measurement by how many decimal places out the measurement goes. Now, I know when you're in math class and you do a calculation, the calculator gives you an answer that goes out like 15 decimal places. And the math teacher usually tells you, or the math regents exams usually tell you, express your answer to the 100th place or express it to the 10th place. What they're doing is they're telling you what precision they want the answer to, what decimal place. In a science class, we're not going to do that. We are not going to tell you what decimal place you're going to round your answer to, because the answer depends on the precision of the measuring instrument that was used to give you the value. The tool you use determines how exact the value is. And this is why as technology advances, back pre-digital technology, we would measure time with an hourglass. Do you know what I'm talking about, an hourglass? Some of the board games I have at home have a little hourglass. You have a certain amount of time to describe something. If I'm playing Pictionary, and when that time runs out, my teammate didn't get it up, we lost our point. The next team gets a turn. And then you turn it and the sand comes down. That's how you would measure time back, way back. Is that how we measure time anymore? No, we either use a clock or a stopwatch, something digital. And when you get to like the Olympics, when they're measuring time in races, they're using lasers to do that time. You got to cut a laser beam. When you cut the laser beam, it starts the stopwatch. When you cut it again, it shuts it off. That's what they do at the track when they're timing the horses going around. It's the same thing. So the more digital becomes, the more exact it becomes. And that sets how many decimal places we can record the time or whatever the measurement is. So it's important to understand the number of decimal places is what's determining it. And you will have to figure out how many decimal places you're allowed to go to based on the instrument you have. So you're not going to say, Ms. Famo, so what number do I write this down to? You're measuring with the ruler. I'm going to say, okay, what's the rule for the precision of this? And that's what we'll be looking at in a minute. Now, before I go on, let's review the decimal places. Because when we talk about precision, I'm going to ask you, how precise is this measurement? And you're going to say, it's precise to the 10th place, or it's precise to the thousands place. So let's just review what those places are from, 5th, 6th grade, just to make sure we're all on the same page with what those places are called. Let's do a 2-digit number in front of the decimal point, and let's go 4 decimal places beyond. I don't think we're going to see much that goes beyond 4 decimal places. So this decimal place here, I'll get you started. This one here is called the tens place. The digit that goes there is in the tens place. Does it make sense? You've heard that before? Okay, what's this one? Ones. What's that? Tenths. This one? I think I'm spelling that right. This one? Thousandths. And this one here? 10,000ths. Okay, so the more places we can write the answer going to the right, the more precise it is. That's what that means. Okay, so let's look at this example. Let's say I had 4 students in the class. We're given a mass that said 1 kilogram on it. And I had 4 different tools in the room. I had a triple beam balance. I had a digital scale. I had other mass balances, a variety of mass balances. The students went, made their masses. They took the masses, wrote them down with the correct precision for the tool they had. Which tool was the most precise measuring tool based on the measurements you see? A, B, C, or D? Who can tell? Yes. It is C. How do you know? Yeah, what decimal place is it going to? The thousandths place. That is correct. This is the most precise measurement that was made. This had the most sophisticated tool to make the measurement. Which one's the least precise? So it's the opposite. Which one is the least precise of those? Which one? I heard somebody say it. D, that's right, because this only goes to the ones place. So instead of going furthest right, it's which one had to end furthest to the left. So D is the least precise. C is the most precise. This went to the thousandths place. This is only to the ones place. In order of precision, in terms of increasing precision, least precise, then next least, and then this is the next least or the most. It's like a double negative there. Okay, any questions on that? All right, so let's talk about different types of precision with measuring tools. Let me show you some different measuring tools. No, that's the wrong camera. It's not detecting this one. Close it out and we'll try it again. Technology is great when it works. If it doesn't work, it's not so good. All right. I'm going to show you 3 different rulers, 3 different metric rulers. I have these printed out because my AP physics class used these today for a lab. See the difference? Any idea which one of those is the most precise ruler? Which one would enable you to make the most precise measurement? Caroline? Yes, it is the bottom one. Now, how did you figure that out? You are correct. That's exactly right. So the top ruler, do you see how that only has, it's indicating the number of centimeters, but to the nearest 10? We would say the precision of that is actually to the tens place. You're going to be guessing, therefore, how many centimeters to the ones place your measurement goes. You could guess, oh, it's 4 centimeters or 7 centimeters. But for you to say with the top ruler, it was 5.632 centimeters, I'd be like, where the heck are you getting all those decimal places from? We can't get them because this is not a precise ruler at all. This can get us to the nearest 10 centimeters. This one is the next most precise, but it's still not as precise as this because the precision of this ruler is to the ones place. You see that? What is this one precise to? You know what those little divisions are? Tenths of centimeters. Okay. So the rule with how we use these, that's what I want to talk to you about here on our next slide, is how you make these measurements, is that we have to first read the instrument, whether it's a ruler or a mass balance or a clock or a graduated cylinder, any of those kind of things. Read the instrument first to its smallest division. So when I'm looking at those rulers, like the top one, the smallest division was the tens of centimeters. So you're just going to read it to the nearest 10 centimeters. Then what you have to do is go one step beyond that and estimate the measurement within a part of the division, one more decimal place. You're going to guess the next decimal place. Estimate the next decimal place position. And that's how we use precision when we make measurements, if we're doing it correctly. We want to think like a scientist. That's what we have to do. And that's what determines the number of decimal places you see on the page, is the tool. So if we just arbitrarily ignore decimal places or add decimal places, you're changing the measuring instrument that was used. and using either a more precise or indicating you used a more or less precise instrument than you actually had. Okay, I want to go one step further then. Everybody set with this slide? Okay, let's look at an example then. I'm going to go back to these rulers. Let's use this ruler here, which is not a common ruler. And let's say I have this piece of paper. Let me fold it up a little. What do I have on my desk that we can measure? This glue stick. I have a glue stick here. Let's say I want you to measure the width of this glue stick. I know what I'm going to do. I'm going to take the cap off. Can we measure the diameter of that? Diameter meaning across. How wide is it? Okay, with this ruler, there is a clear 0. So I'm going to put one edge here on the clear 0. Oh, but you see, it's not under the camera lens, so it's a little hard to read. There we go. We have to guess where we are here on this, and there's the 10. Anyone want to take a guess how wide that is? What decimal place are you going to tell me it goes to, first of all? The ones, yeah. Your guess has to go to the ones place. It's between 0 and 10, so it's less than 10. And since this is only showing you tens, you can only guess to the nearest centimeter how big that is. You want to take a guess? If I were to divide that into 10 equal divisions, what do you think it is? Your guess is as good as mine. If I said 1, you said 2, somebody else said 3, fine. We can't really tell, can we? This is not very precise. If I do it with a different ruler, like this one, you think you're going to be able to guess better? Absolutely, because it's more precise. So I'm going to do the same thing. I'm going to line up the left with the 0 because it's clear to read. I'm going to put it directly under the camera lens. So that way we can try to read it accurately. Now, what decimal place would you tell me this goes to? What would you approximate it to? The tenths. Do you see how the right edge is a little bit beyond 2? Can you see that? So your answer would be 2 point something centimeters. If it's right on the 2 line, it would be 2.0. If it's a little beyond, you would say 2.1 or 2.2. But we couldn't say 2.15. Why can't I say it's 2.15 centimeters with this ruler? It's not precise enough. I don't know where the 0.1 and the 0.2 centimeters are. So how can I know where the half of the tenth of a centimeter is? There's no way to figure that out. Okay. So let's now practice making some measurements. Where am I going? I need to go back to the Google Meet to share the presentation again. I have something in the presentation that we're going to measure together. This right here. I want us to measure the length of that metal strip. I want you to notice something for a minute. You see the metal strip on top of that little segment of a ruler? Yes? Okay. You see how the left edge is not at a 0? Very often, we can't start at a 0 on a ruler. I'm going to show you why. Look at this meter stick. Do you see a 0 on there? How about that meter stick? Do you see a 0 on that one? Very often, unless there is a very clear 0 marking on the ruler, they can't start at 0. So what do? We just say, just plop something in the middle. And then if I want to get the length of the strip like this, so this ruler didn't have a 0. So I'm going to start anywhere I want. I would have to measure this side, get like a reading for where is that, get a reading for what's over here. And then if I want the length, do you know what I have to do? I want to know how long it is, but I have those 2 readings. What would I do? Subtract. That's what we're going to do. Okay. Because when we do things in our class with these wood rulers or wooden meter sticks, we're out of luck. There's no 0. But we can try to make our life a little easier than I did here. Move the strip to an exact even number. It's a little easier to do the subtraction in our head. Okay. For now, we're going to do this one together. And when I look at this, you're going to hear me refer to the left side of the strip and the right side of the strip. Left side, right side. The left side number will be smaller. The further we go to the right side of the strip, the bigger the number is. Okay, here's my next question for you. What decimal place will we make our measurements to with that ruler? When we write them down, what decimal place are we going to write them down to? Based upon the rules we just talked about for precision. Think you know?
100?
Yes, because the little divisions, right, these are centimeters. These are what? Tenths of centimeters. So we're going to go one more place to the hundredths. Okay. Now this ruler is a little easier to read with because it's been enlarged. When you get an actual ruler, those little tenth place divisions are really tiny. Those are millimeters. A tenth of a centimeter is a millimeter. They're really close together. Sometimes what I do is I put my, especially because as I'm getting older, my eyes are getting worse. And even with my reading glasses, I sometimes can't count the little lines. Sometimes what I do is I grab a magnifying glass if you happen to have one of the old magnifying glasses. Or what do you do you take a picture of something and you want to enlarge it. Yeah, just zoom in. You can do the same thing. Except in class. You're at home, take a picture, zoom in, and now you got it. Okay, that way you can read it. Sorry, it is what it is. But you could take a picture with your Chromebook and then zoom in on your Chromebook screen. Although the camera on your Chromebook is not so good, is it? I know. Sorry. Okay, so let's do this together. We're going to start with our bigger number, the right side. Since we can easily read the ones place digits, we're going to get our first digit in the ones place. We see the right side is somewhere between 5 and 6. So the first number we're going to write in the ones place is a 5. It's not bigger than 6. It's less than 6, so we have to go with 5. Okay, now the 10th place digit, we count the little lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. We're between the 9th and the 10th line. So what number am I going to put in the 10th place? A 9, because it didn't get to 10. Now this digit is the one you're going to estimate. How far are we between the 9th and the 10th line? What digit do you want to put there? If you think we're exactly halfway between the 9th and the 10th line, what number would you put? A 5, right? Because that's halfway between 9 and 10. What do you want to put? It's your guess. Your guess is as good as mine. Although I wouldn't say it's 0. It's not right on the 9th line. It's not right on the 10th line. It's somewhere between. What do you want to go with? Somebody give me a number. Great. Now you have to do the same thing on the left side. So what digit are we going to put in the ones place? A 4. Yeah, because this side is between the 4 and the 5. Count the little lines. This is 0, 1, 2. So we're between the 1 and the 2. So what number do I put in the 10th place? A 1. You have to go with the smaller number. Next digit is your guess. How far do you think we are between the first and the second line? I hear a 3. Let me go with 3. Notice I follow those numbers with centimeters. If I didn't put a unit, would you know that they were centimeters? No, they could be miles, they could be seconds, they could be pounds, they could be apples. We don't know what they are. It is really important in a science class, or if you're doing science after you leave the high school, that you put units after your numbers. That's one thing that separates mathematicians from scientists and engineers. Scientists and engineers need those units. A mathematician is just dealing with theoretical numbers, numerical patterns, but not measurement patterns like we are. Now, to come up with the length, we're going to subtract. This is still centimeters. 4 minus 3 is 1. 9 minus 1 is 8. 5 minus 4 is 1. So the length of that strip, we would say, is 1.81 centimeters. Okay? Questions? All right, let's practice. This. And let me just make sure my document camera is going to be shared. It's not. And I know the Bluetooth just kicked off with the projector. I'll fix that too. I will tell you, you see how it kicked me off? That doesn't happen in any other class but end of the day. Why? I do not know. It has happened that way for 3 years since we got these Apple TV things. Well, it used to be an Apple TV. It's not an Apple TV. I don't know what it is anymore. I think it's a Microsoft. Okay. This is your Unit 1 packet. Or you can think of it as a workbook. Every unit in the course is going to give you a workbook with practice questions, homework worksheets, review questions for tests. You're welcome. So you don't want to lose this. This is yours. If you do lose it, like I showed you, it is uploaded into Google Classroom. So you can always print out whatever you need. That's also a good thing, being uploaded to Google Classroom. Let's say you leave this at school, but you need it to do homework. You can always go to Google Classroom, look at the packet that's online, and then just print off what you need or write it separate in your notebook. Okay, the first page is what we're going to look at today. These are extras. And this is our practice with precision. On the top, I'm going to put my name. You can put yours there too if you want. And this is my period. You are my period 8 class. So I'm going to keep period 8 on there so I know I don't mix it up with my other classes. All right, so here's what we're going to do on this page. There are 4 meter sticks given to you here. 1, 2, 3, and 4. Number 1 has already been done for us. What we want to do is not only measure the length of this object, which is hashed, that bar. We want to measure the length of that bar. This is a meter stick. This left edge is 0 meters. This edge over here is 1 meter. Okay, that's true for all of them. So this is 0 meters. This over here is 1 meter. You'll see, based upon which example we're looking at, that the meter stick has a different number of divisions in every case. If I look at this first meter stick, what are those little subdivisions? How much of a meter are they? Tenths. And that's what it tells us, that meter stick is graduated into tenths of a meter. Graduated means broken down. Those are those subdivisions, tenths. 1 tenth, 2 tenths, 3 tenths, 4 tenths, 5 tenths, 6 tenths, 7 tenths, 8 tenths, 9 tenths, and then a meter, or 10 tenths, which is 1 meter. Then we have to guess one more digit like we were doing on that example. So we're going to measure to the 100th place with this meter stick. We then count 1, 2, 3, 4, 5, 6, 7. I'm between 0.7 and 0.8. So this student guessed 0.73 meters. Okay? You follow what you have to do? Excuse me. So in number 1, what are those small subdivisions? How much of a meter are they? Those are hundredths of a meter. So let's write this out. The meter stick has subdivisions excuse me, to the 100th of a meter. So this measurement will go to what decimal place? The 1,000. Of a meter. Now there's a line for you to write your answer in meters. Please put a little M at the end. That's the abbreviation for meter. So we know what it is. First thing we're going to do is we're going to figure out the number of tenths by counting the longer little lines. This is 1/10, 2/10, 3/10. So which are we going to write? 0.2 or 0.3? 0.2. Now we got to count the little lines in between. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. It's between 8 and 9. But does that look like it's right on 8 to you? No? What do you think it is? If it's not right on the 8th line, what is it? I'll zoom in some more. See, I have a camera. I can do that. What would you put? I'm counting these little lines between 1, 2, 3, 4, 5, 6, 7, 8. There's 9. It's around 8, isn't it? Is it right on the 8th line? This edge here, to me, it looks like it's lined up perfectly. So I'm going to put 0.28, but then what do I have to put in the next digit since I have to go to the thousandths place?
0.
A 0. And that would be an acceptable answer. Now, in terms of a tolerance, we always give you plus or minus 0.2 of the measurement you have. So in this place, since that's your estimated digit, we expect you to be within 0.002. So if you said 0.278 to 0.282 meters, I would give it to you. But if you just wrote 0.28 meters, that's going to be marked wrong. Why would 0.28 meters not be a correct answer for this ruler? This would not be given credit. Why? You have the wrong precision. You're telling me if this is your answer, this was not your ruler. It's telling me you used this ruler here instead of this one. The precision is important because you are communicating to the person looking at that measurement which tool you use to make the measurement. It's really important in science for that. Okay, let's look at the next two. I want you to try 2 and 3 now on your own. These are both in meters, so you can add the meters there. Not only are you going to give me the measurement, you're going to give me the explanation as to the precision that you are recording your answer to. All right, how about this? You can go ahead, take your break. When you come back, we'll look at what those answers are that you recorded and make sure we all get it before we move on to our lab. Okay, go ahead, take a break. If you need to use the restroom, now is the time to do that because now you don't need a pass to go. Oh my goodness. All righty. Let's look at number 2, shall we? What are these subdivisions? What did you write down that those subdivisions were on that meter stick? Yes. Yes, that's right. Those subdivisions are to the 10th of a meter. So that means that this measurement should go to what? Yep. 100? Yep, that's right, to the 100th of a meter. All right. So then if you put that as your rationale, something to that effect, that we see tenths of meters, so we have to go to the hundredths place, that's correct. That is how we determine the precision with this tool. So what did you put down for your measurement? Who can give me a measurement? Yes. I agree with that. I am going to give you plus or minus 0.02 on that number. So if your answer is between 0.39 and 0.43, and it's to the hundredths place, it's good. How many of you got that right? Great. Give yourself a star. I am a huge proponent of congratulating yourself when you do good work. Okay. How about number 3? What are the subdivisions on this one? That's right. So this meter stick has subdivisions to the ones place. So the measurement should go to what? That's right, to the tenths place. All right, so what do we think the length of this is? It's got to go to the tenths place. What do you think? Yeah, that's what I said too. But again, you're going to get plus or minus 0.2. So if you said 0.3, 0.4, 0.5, 0.6, or 0.7, any of those answers are okay. But 0.51 is not. That's the wrong precision. Okay? How many of you got this one right? Yay! Good. Okay, this packet, put it away. Put it in your physics binder or your physics folder, wherever you're keeping things. That was what today's lesson is about. Now, if I go back to the Google Classroom for a minute, let's talk about the homework. The homework for Monday, there is a written assignment besides getting your course outline, the safety contract signed. A lot of you have already done that. Check. Yes. You got to get your supplies. We need everything for Monday. In particular, you're going to need your ruler like this weekend to do the written assignment that I'm giving you. So you need to find a ruler somewhere in your house that has metric on it and use it to do your homework, but bring the ruler to class on Monday. You're going to need your own ruler here. I want you to start getting used to your ruler. Not one of mine, one of yours. I'm going to give you something to make measurements of. And then your assignment will be to make those measurements in centimeters with the proper technique, with your ruler, and the proper precision of your ruler. Now, what is it that I'm going to ask you to measure? Wow, let me hand these out and I'll explain. Just getting one of these cards with some things on them. These are common supply items. And there are 4 things here. Let's just make sure we know what they are. The 4 things include this index card, a paper clip, take that off, a small Post-it, and a large Post-it. Okay? On the back of the index card, here's what I'd like you to do. I've written this down 3 times today. Instead of rewriting it, I'm going to do this. You are going to measure the length with your ruler of those 4 items. On the back of the index card is where you can record those measurements for the lengths in centimeters. So the first measurement would be for the length of the index card I just gave you in centimeters. You can put a blank with the centimeters after it. The next item you're going to measure the length of is the large Post-it, again in centimeters. The third is the small Post-it in centimeters. And the fourth is the paper clip in centimeters. You're going to put it right on the back of the index card. Now, the word length can be kind of confusing. I want to make sure we are all on the same page in terms of what is meant by the length of something. So this index card is what shape? Oh, really? Come on. What shape is the index card? Okay, thank you. It's a rectangle. And what we learn in, I don't know, when do you learn that that's a rectangle? Kindergarten, maybe, first grade, something like that. A rectangle has two long edges and two short edges, right? Okay, when I'm talking about measuring the length, I want you to measure the long edge. Length is long. Length is long. So when you're looking at this, I want you to measure from here over to here, straight across. That's what we mean by length. If I'm doing that for the large Post-it, it really doesn't matter, does it? Because that's a square. Squares have equal sides. All four sides are equal length. Doesn't matter. The small Post-it, again, is a rectangle, so you need to measure the long edge, either the top or the bottom edge. And your paper clip, what the heck just happened to my paper clip? When I'm talking about its length, you're talking about it from here to here, in between my fingers. Okay? That's the length. Questions? That's your written assignment for Monday. I want you to practice measuring. Now, we're going to do some practice measuring in class right now with our first physics lab. Everyone will need a pencil, not a pen. If you have a pen, put it away. The only time I really want you to have a pen is when we take a test. This is not a test. Pencils you can erase with. So I'd like you to use a pencil. If you need a pencil, come on up. I've got a bunch here in this green tin. That is true for any day. You need a pencil, come on up and get it. These pages are sticking and it's driving me bananas. I don't like bananas. That's why it drives me bananas. Do you all like bananas? It's a consistency thing for me. Like stop. I love strawberries, so I would never say it's driving me strawberries. That would be a good. Or driving me chocolate. Oh my God, love chocolate. You ever want to put me in a good mood? Feel free to bring in chocolate. The darker, the better. Hey, I'm a woman, single woman. Chocolate is it. That is the bomb. That and ice cream. Oh. This time of year it's soft serve. Favorite soft serve? You know where I like to go for soft serve ice cream? Scoops. Do you? I was there all summer long, trying to bring all the different pups to get them pup cups. The first ever pup cup. It's so cute. Take a little video, put it up on social media. People go wild for that, and then they want to adopt the puppy. It's great. So, what we try to do for these dogs that we love. All right. Anyway, and I'm so glad to see some of you have dogs. I was reading that on your sheets last night. I'm like, yes, another dog person. You're my people. So when I come in covered in dog hair, because I go home every day, 7th period, before your class to let them out and give the puppies lunch, because they got to eat lunch. 3 times a day they have to eat, the little ones. So I go home. If I come back covered in dog hair, you'll know, oh, well, they just jumped all over me. And you'll be like, yeah, no problem. I'm not a cat person, but definitely a dog person. Cats are not my thing. If you have a cat, I'm sorry. I don't mean to offend you. Okay. Fish are okay too, but they're not as cuddly as a dog. Any of you sleep with your dogs? You do? on occasion. I'm actually allergic to dogs. So the fact that I have 5 of them at home is not, this is why I'm always like congested because I have dogs. But I go for allergy shots to try to help with. I'm like, I'll just stick another needle in my arm. Give me another shot so I can have another dog. I'll take that anytime. Anyway, I told you I go on tangents. You've been warned. Chocolate, ice cream, and dogs. So let's go ahead and put our name on top of the lab worksheet. All your labs this year, I shouldn't say all, most of your labs are worksheets. Okay. Go ahead and put your name, not mine, where it asks for your name. This is what I will be collecting and grading from you when we are done with the lab. We are not doing that much with this lab today because you don't know enough of the science or the skills that we need to do this yet. All we're going to do today is complete these 2 data tables. Let's just look at what the data tables are asking us for. In the first table, we're going to be recording length measurements. And in the second table, we're recording width measurements. So that begs the question, what are we measuring, right? What do we want the length of? What do we want the width of? It's this piece of paper. You're going to measure the length of this paper and the width of it. Remember, length is equivalent to which side of this paper? This, the top, or the side? In this case, it's the side because that's the long edge. Now take a look. You'll see that I'm asking you to do this right side, left side gives you the length. Remember how we did that with the metal strip in that example? We got a right side reading and a left side reading. Then what did we do to get the length with those 2 numbers? You're going to subtract them. So if you want to put a subtraction sign and an equal sign there to remind you that's what you need to do to get your length measurements, and the same thing for your width measurements, be my guest. I'm not going to be grading that part of it. That's just for you. Now you'll notice that each table asks you to make 4 of these. You individually are not making 4 lengths and 4 widths. You individually are going to do 1. In a group, you're going to get 4. Each person in the group is going to be assigned one of these numbers. That is your row to fill in. Where are you going to get the other rows? From your partners. Does that make sense? So you're only doing 1. I do have calculators. So if you need help with the subtraction, you don't want to do it in your head, I'll give you a calculator. But I suspect some of you probably have a calculator in your backpack from math class. You can pull it out and use it when we get there. I just want to remind you of a couple things. The right side is going to be the bigger number. The left side is going to be the smaller number. Now, this is weird because the left side is in the right column. So sometimes I see kids, when they just take the meter stick to measure something, they reverse them. So they write it down, like they stick this over the top, and this number they put here because it's on the left of the, no, it's got to go over here because that's going to be the smaller number, okay? So just make sure you put it in the correct column. The other thing I need to talk to you about, what the heck? I'm going to do one of them as an example. I'll do the width. I'm going to give you an example of what I should be seeing here. So I'm going to do it. You can just write it down if you want, or I'll just leave it on the screen for you to look at to make sure you're doing it correctly. One of the issues we have when we use this meter stick, again, there's no 0, so you're not going to start at 0. That's why we're going to need 2 numbers. One thing I'm going to encourage you to do is put the left edge on a whole number, an exact number. So what I'm trying to do is line it up with the 5. This is weird. My camera is over the top of it, but does this, make sure it is lined up. That is lined up. That 5 is over the left edge of this paper. Does it look that way to you on the camera? This 5 here, that line does not look like it's lined up with this edge of the paper. The paper looks like it's too far to the right. Yes, it's not. It's exactly on top. Let me show you. This is an error that you will run into if you are not making your measurement correctly. When you read your ruler, your eye needs to go directly over that line, over this edge of the paper. The camera's eye is over here. The edge of the paper is over here. They're not lined up. Okay, so look down here on my desk. The camera's eye is here, where my hand is, over here. This is where the edge of the paper is. Those are not in alignment. So what I need to do, if this is your eye, the camera's eye is your eye, you need to move your eye from here over to here. So when I do that with the camera, look at what happens. You see how now it shifts and it actually lines up? That's a type of error called parallax error. It's as if, you may have experienced this before, you're driving your car or someone else is driving the car and you are in the front passenger seat. You look over at the speedometer, that's an analog one with a needle, that the needle goes up as you speed up. You slow down, the needle goes down to 0. If you're the passenger and you look at the speedometer, you will not be able to see the speed on the speedometer correctly. The only person who can see the speed on the speedometer where that needle is correctly is the driver in the car. So you want to make sure you are like the driver in the car. And the way you do that to make a correct measurement is you take your eye and you look straight down over the edge. Don't be over here looking at it. Don't be over here looking at it. That's not going to work. You have to get your eye over the top of it. Okay? Otherwise, you introduce parallax error, and that's a huge problem in science. Okay, anyway, my example. My left edge is at 5. Back up. Can you see the right? No, you cannot. Move the camera eye. Okay, this side, the right, for me, is at 26.53. That would be my measurement. Now, are you going to have to write centimeters after every number when you're filling out the table? Why not? I'm sorry? Where? In the column headings. That's a shorthand way. When we put them in the column heading, you do not have to write them down below. It's assumed they're the same. Okay? I'm putting it above it because it's not in the table, as an example. This is what I need to see. I'm going to assign each of you to a group. Each group is going to be given 2 meter sticks. This is a meter stick. It's about the length of your desk. So 2 people sitting next to each other. One person can use this side of the meter stick. The other can use this side. You can make 2 measurements at the same time. You understand what I'm saying? This postnasal drip from the doggies. It's okay. Good deal. The other thing, each of you is assigned a number for your group. So if this is a group of 4, you're going to make measurement 1 for everybody. You're going to make measurement 2, 3, and 4. Be consistent. So that way when I look at your tables, they all look exactly the same. Follow? Okay. You're going to do 1 length, 1 width. Share data, and then return these to me. And then we'll talk about how to do the averages. Okay. Let me get everybody meter sticks. We're going to have 5 groups. 1, 2, 3, 4. 1, 2, 3, 4. It's a lousy meter stick. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Help each other do this. You may want to circle your number so you don't forget. Which one are you in your group? Okay, group of 4. 1, 2, 3, and 4. And then you are a group of 4. 1, 2, 3, and 4. Okay.
Wait, let me just, that's
Let me know if you need help. You can ask your partners for help also. And I'm going to make up some fictitious data. Actually, it was not fictitious. This is a student's lab from a couple of years ago. Who did it? I'm going to copy their numbers. Use your numbers, not mine. I'm just making stuff up. Well, kind of, sort of. Let me pull up my calculators. If you need a calculator, you can come up and borrow one. I'll put them over here. It's at the end of class. I just returned it. You will need a calculator to do the averages. So if you have a calculator, you'll need to pull one out. Are you both done with your measurements?
Yeah.
Okay. Are you both done with your measurements?
Yes.
Okay.
Great job.
Okay, go ahead and copy each other's now. Are you both done?
Let's get in on that.
Just make sure you keep everything to the same precision, right? Everything's got to stay to the hundredth place.
Oh, I'm keeping my
Good? Are you both good? Excellent. Are you both all set?
It's just
What's wrong with those two numbers? No, it's not that they're the same. This whole lesson is about precision. So one has to be true about this. Yeah, it is as well. This one is not to the correct place, nor is that. Everything should go to the hundred. So I'll leave that there in case you need to remeasure. Are you both done with your measurements? Okay. Are you both done?
Yeah.
Are you both done?
Oh, no, it's 20. Oh, yes.
You guys are with it. This is the first class today that did not have an issue with this lab. My other classes were like, we don't get it. Don't overthink it. Not supposed to be, this is not rocket science. We'll get to rocket science later. Well, I'm going to show you how to do them in a minute. You're going to need a calculator too. You're not going to want to trust each other on the math because if you mess up the average, then everybody loses credit on the list. You want everybody to double check. Okay. So if you need a calculator, I have calculators over there. You can grab one or you can pull one out. I'm going to walk everybody through how we're going to do it. Oh, well, let's see it. Oh, you're the Casio. I hate Casios. On the Regents exam, I'm probably going to swap calculator because we have to clear calculator numbers, and I don't know how to do this.
That's what I was trying to figure out too.
Where did you get this calculator?
My mom.
Your mom just bought it brand new.
Yeah.
Can she return it and get another one?
I think we can. I saw the box.
Okay, if you can return it to get a TI, those are the, well, they're a little easier to work with. What do you need? What math are you in this year?
It's 6, 8.
Okay, so you probably don't need a graph. Do you need a graphing calculator?
And then minus 8.
You do.
And then we get
These are easier to
27.
work with.
6.
These I sorry.
No,
That's why I'm like, I'm looking at them. I don't know how to clear it out for you. I'm sorry.
well, like I like my on like this was the first thing. That
Oh my gosh,
I'm like,
yeah, no.
how do you?
This is too complicated.
My mom always said I need to replace it.
Get the TI. TI 84. You can even Marketplace. You can get them for really cheap. You know what I mean by Marketplace? Facebook Marketplace.
I go on
People are selling them for like nothing. Yeah. So that's where I got my daughter's TI calculator.
Yes.
Yeah. Oh yeah. Because I'm like, I'm not spending $110 on this. No, she wants to be a musician. There's no way. No way she's going to use the graphing calculator beyond high school.
That's how my mom felt when she first bought me the first one.
And I think it's ridiculous that all your courses need different calculators. Like, no. It should be one calculator, one purchase, gets you through all of middle and high school, and you're done. But anyway, how are we doing with the data in the two tables? We haven't done the averages yet because I want to go over how we do them here to make sure, because it's a little different than what you do in math. Oh, you're all like, what? It's different than the math? Yeah, because this is science. We have to be complicated. We have to be annoying. Sorry. We're just very particular because these are not arbitrary numbers. Okay. So double check a couple things. Notice that your numbers are not mine. You did not copy my tables, but we should see the same patterns, that all the data that you wrote by hand in the right side column, the left side column, and the lengths all go to the hundredths place. Nothing isn't going, they all go to the hundredths. Same thing for your widths. Everything you wrote down goes to the hundredths place. Yes? Okay, next thing. Let's double check that everything makes sense. All of your lengths, even though they are not exactly equal to each other, should be about the same. Like these are all somewhere between 27 and 28 centimeters. Yours should be too. If somebody got an answer that was 29 centimeters, they didn't read their meter stick correctly. They need to go back and redo it. Same thing with your widths. Notice that even though all my widths are different, they're all between 21 and 22 centimeters. That's what we're looking for. Some consistency. All right. If something isn't, we got to fix it before we do the average. Okay. You'll need a calculator to do the average. Everyone is going to do it. You are not going to rely on your group members. Instead, what we're going to do is we're going to do them, and then you're going to check with all of your group to make sure you're all getting the same thing. Because if you rely on one person to do it, and they mess it up, now you've all lost the credit. Now you're going to be upset with them. Don't be. Just check their work, okay? We're all going to do it. Here's what you're going to do. If you need a calculator, again, they're over there. You can borrow for today, but next week you'll need your own. Come on, Jacoby. Hurry, hustle it up. All right, here's what we're going to do. First thing I want you to do is add your 4 lengths together. Just straight addition. Straight addition. Get an answer. Okay, that is the answer of these 4 numbers added up. Now, what do you do with that sum to get the average? Okay, so go ahead, hit divided by 4. And that's what my calculator gives me. And that is not what I'm going to write down for my average. I'm not. There's an issue with that number. Look how many decimal places my number goes to. What decimal place is this? That's the thousands place. Do I have anything written down that goes to the thousands place? My average can't go that far. It's too precise. When we do an average in a science course, in real life, in engineering, the average of the data should have the same precision as the actual data, which means that what decimal place do I have to end this number at? The hundredths. Okay, here's my next problem. That is a 5. We follow rules for rounding. You know what the rule for rounding is? When that digit, the one right after where I need to end is a 5 or bigger, we go up. So instead of this being 79 here, I have to round it up to 80. So my answer for my average is 27.80. You have to figure out what your group's is. Okay? Do yours, check with your team. Make sure everybody on the team agrees that that number you got is the right one. If yours gave you a perfect hundredths place, it's easy. But that's not always going to happen like you see here. All right, can you do the same thing for your width? Add up your 4 widths. And then take that sum and divide it by 4. Mine worked out perfectly to the hundredths place, so I don't have to round this time. But you might have to. Check with your group. Make sure everybody agrees on what the average is. All right. If everyone on that group agrees on everything that you've done, you can then put this in your physics binder or your physics folder. You are not doing any more of this now. And we won't for about 4 or 5 days. We have to learn a lot more stuff before we can answer the questions correctly. Okay? So just put that away, which means we have, geez, what time is it? 1:59. It means we have 7 minutes to make those measurements on that index card and Post-its. If you have a ruler, go ahead, pull it out. If you don't, I'll loan you one to use right now, where you can work on getting your measurements. Who needs a ruler? Welcome. Use the metric side. You're welcome. Anyone else? Don't use the side that says inches. Do they even say inches? No, it's the smaller side that goes to 15. That's the metric side, okay? Anyone else need a ruler? It's longer than 15? Oh, then you're going to have to use a different ruler when you do the for homework. But you can do all the other ones, right? Just don't do the index card, do all the others. Or, if you want to come up and use a meter stick, you could use a meter stick as well. Same precision, right? This is all about precision, using the precision of your meter stick. Perfect. And you can start right at zero. You don't have anything to subtract. Well, you're actually subtracting zero. Anything minus zero. Same
Zero.
thing. Yeah. Well, yes. So I say if it's a clear zero, you're in good shape. If it's not, that's where you have to do the subtraction stuff. Yeah, that's right. I think it's longer than 15, but yeah, you should be able to do the others. Somebody left a ruler behind last year at the Regents exam. You need a ruler and you don't want to go buy one, you can have this one. That was left behind at the Regents exam last year.